Alright, to attack these classic mixture problems, I use this chart to organize the information. First, what I'm going to do is input the information that's given in the problem. In this case, we need to get to a 70% solution. We're mixing a 60% solution with a 95% solution. And this final mix that we're trying to get is going to be a 70% mix. Okay, and then the next thing I do is fill out this rate column. In this case, the rate is the percent of alcohol, and so this is pretty straightforward. The 60% solution, the rate for that is 0.60. The decimal version is 60%. The rate for 95% is 0.95, and the final rate is going to be 0.70. Okay, the quantity is the amount of stuff you're going to be using. In this case, we're looking at what we're dealing with, milliliters. So we're dealing with the milliliters of stuff that we're going to be dealing with. We know we have 350 milliliters of the 60% solution. We don't know how much of the 95%, and we don't know how much we're going to have in the end. What we're going to do then is attribute variables for the unknown amounts. We're going to give X milliliters for the 95% solution, and then Y milliliters for the 70% solution. And then what we do is we fill out the amount column. It always works like this. We fill in the information for rate and quantity, and then the amount column always comes by multiplying our rates and our quantities together. So this first number is 0.60 times 350, which gets 210. The second spot here is 0.95 times x, which is just 0.95x. And then 0.70 times y is 0.70y. There are other ways to solve these mixture problems and not using this type of table. All this table does is really organize our information and to give us exactly what we need to put in for our variables. The beauty of this is if you can fill this table out correctly, and again, what we do is we enter all the information we can for the rates and the quantities, and then we multiply those together to get our amount column. Our equations that we're going to use always come from the quantity and the amount columns. What we're going to do are add the two that we're mixing together to equal our final mixture problem, our final mixture column. And the second thing over here, we add those two values to get our final value here. So the two equations that we get from this are 350 plus x equals y. What that says is the 350 milliliters plus whatever we add of the 95% is going to equal the final amount that we have. And then the amount column gives us 210 plus 0.95x equals 0.70y. This is the system of equations that we would use to solve this problem. We now can solve this system using either addition elimination or substitution. I'm going to choose to do this by substitution. What I'm going to do is substitute this value for y in right here to the second equation. So I'll get from after substitution, I get 210 plus 0.59x equals 0.70, and then parentheses here now I have 350 plus x. Then we'll distribute over on that right-hand side of the equation, and what we'll end up with is 210 plus 0.95x equals 0.70 times 350 is 245, and then 0.70x. And then I'm going to combine my variable here, consolidate it to one side by subtracting 0.70x from both sides. And what that will give me here is 210 plus 0.25x equals 245. And then I'm going to subtract 210 from both sides of the equation. And what I have now is 0.25x equals 35. I'm going to divide both sides by 0.25. And that will give me x equals 140. Okay, Now it's important to figure out again what that represented for this equation. So x is 140. What is that? X being 140 here is the amount of the 95% solution. I can find out my y by adding 350 and that value. So let's go down and do that. So 350 plus x, which is 140, equals my y, and so I get 490 equals y. So the solution to this system is x equals 140 and y equals 490. What that means is that I have 140 milliliters of the 95% solution that I'm going to add. I'm adding that to the 350 milliliters that I had already to get a final amount of 490 milliliters of solution that's 70% alcohol.